Hello guys, I am Mark Antonio Mago and I am here to present my project and its title is 3D bioprinting, an important step to medical innovation. We know that when an individual needs an organ transplant, it is because one of their organs is functioning very poorly. Undergoing an organ transplant will help extend the life of a person and allow a normal lifetime for those with a chronic disease. There are organ donors who help and save other people's lives by donating their own organs. One organ donor can save 8 lives. But as time goes by, many people needs an organ transplant, but since we do not have enough organ donor, many people died waiting for the transplant to happen and waiting for a donor. But now that we have advanced technology, there is a technological innovation that will help many people to get an organ transplant and they don't need to wait for a donor. And this technology is called the 3D bioprinting, which is presented in the screen. This will end desperate state of organ donations and it could be the solution for organ shortages. Scientists have been developing cells from different organs in laboratories for years, including skin tissue, blood vessels, and other cell cultures. It is nothing really new to replicate and expand cells in petri dishes, and the science surrounding this is continually progressing. 3D printing, however, provides an opportunity for an entire organ to be printed, not just parts of one, because of the cells and other materials used. The expense of these procedures can also be greatly reduced. The first commercially used bioprinter, named Novogen MMX, was made by Organovo in 2014, which is the world's first 3D bioprinter in production. There are two robotic printing heads on the printer. One places human cells and the other places a help of hydrogel, scaffold, or other form, and it is called the bioink. Bioink is a mixture which is a mixture of cells, biomaterials, and bioactive molecules that the printed articles produces is one of the most essential components of 3D bioprinting. Polymeric hydrogels, polymer bead microcarriers, cell aggregates, and extracellular matrix proteins are the most common materials used in bioinks. Hydrogel is often used in between layers to fill gaps in the tissues or to protect the 3D printed tissue. Another substance used to fuse the cells together is collagen. This layer by layer technique is somewhat close to the usual method of 3D printing, where objects are created from the ground up. Since cells are not enough because they need a nurturing environment like food, water, and oxygen, they use microgels enriched with vitamins, proteins, and other life-sustaining compounds as a substitute for the cell to stay alive. The idea of lab-grown tissues could mean the end of testing drugs on animals and humans. Since the technology is not yet mature enough to manufacture a complete organ, the tissue samples are suitable for testing drugs and other medical advances. Bioprinting will offer a much more cost-effective and ethical alternative instead of having to use human beings or animals as guinea pigs for pharmaceutical research, but also being reliable since the tissue samples are made from human cells. With the aid of 3D printing, the future is changing forever. Today, the use of 3D printing for medicinal purposes is beyond surprising, but it is unclear what the future holds. but it is certain that additive layer manufacturing will be a big business to solve our problems. 3D printing is really infinite, and only the surface has been scratched, and there is so much more to be learned. These are some examples of 3D bioprinting. The first one is the bones. This is the second one. The third one is a bionic eye. The fourth one is antibacterial tooth. This one is a 3D printed silicone heart that works and pumps like a real human heart, but it only lasts for about 3,000 beats. In conclusion, patient specialized bone, cartilage, blood vascular network, hepatic unit, and other simple components tissues can be created by 3D bioprinting, but pure cell-based functional organs are still desired. If it will become successful, then it will become the solution to organ shortages, and this will help save many lives. That's all. Thank you for listening. Bye.